let us discuss about the type of flow profiles for steep sloped channel. For a steep slope, S0 is higher than SC or YC is higher than YN. Here also three zones are available. So dy by dx equal to S0 into 1 minus yn by y the whole cube divided by 1 minus yc by y the whole cube. So three type of profiles are available, S1, S2 and S3, corresponding to the position of y with respect to yc and yn. So if y is above yc and yn, then dy by dx is positive or S1 profile is a backwater curve. So you can see this S1 curve is a backwater curve. So initially the position of y is in the zone 1. Second case, y is in between yc and yn. So in this case dy by dx is negative. So here you can see that this is the S2 profile. It is starting from the zone 2 and flow depth is decreasing in the direction of the flow. So that means it is a drawdown curve. Third case, the position of y which is below yc and yn. Since it is a steep slope, always yc is higher than yn. So in this case dy by dx is positive. So we can mark this yc line and yn line. Here our flow depth is starting from zone 3 and flow depth increasing in the direction of the flow, indicating that S3 profile is a backwater curve. Now let us discuss about the practical examples. It is similar to the earlier one, only thing is channel bottom slope is higher than SC or YC is higher than YN. So you can see that the S1 profile is starting from zone 1 where dy by dx is positive. It is a backwater curve. Similarly, for S2 profile, it is starting from zone 2 where dy by dx is negative. So here you can see that channel bed slope is changes or increases from mild to steep. Because of the change in the channel bottom, water surface depth is decreasing in the direction of the flow. In the third case, profile is starting from zone 3 where dy by dx is positive. Because of the lifting of the gate, the flow starts from the small opening here and flow depth is gradually increasing, and you can see that it is a backwater curve or S3 profile is a backwater curve. So here you can see that S1 and S3 are backwater curves where S2 is the drawdown curve. Now let us discuss about the critical slope. For the critical slope, S0 equal to SC or YC equal to YN. Since YC equal to YN, zone 2 is absent here. Only zone 1 and zone 3 are available. That means for critical slopes, C1 and C3 profiles are available. So dy by dx equal to S0 into 1 minus yn by y the whole cube divided by 1 minus yc by y the whole cube. Since y is higher than yc and yn for the zone 1, then dy by dx is positive or C1 profiles is a backwater curve. You can see that flow depth is increasing in the direction of the flow. In the second case, S0 equal to SC or YC equal to YN, that means there is no flow profile. And in the third case, Y is less than YC equal to YN, that means for C3 profile also dy by dx is positive. The profile is starting from zone 3 and flow depth is increasing in the direction of the flow, which indicates that C3 profile is a backwater curve. Now see the practical examples. So here you can see that C1 profile is starting from zone 1 where dy by dx is positive. Here you can see that the slope is changing. So because of the slope change from the zone 1, the water surface depth is increasing. That means it is a backwater curve. Similarly, when y is less than yc equal to yn, flow profile is starting from zone 3 and flow depth is increasing in the direction of the flow where dy by dx is positive. The water surface profiles correspond to the critical slopes. Both C1 and C3 profiles are backwater curves. Now consider the water surface profiles for the horizontal slopes. For the horizontal slopes, yn is infinity and S0 equal to 0. Since yn is infinity, zone 1 is absent. Only zone 2 and zone 3 are available. That means for horizontal slopes, H2 and H3 profiles are available. The first case is y which is higher than yn and yc. So since yn is infinity, so this condition cannot be satisfied. That means h1 is totally absent. And the second case is y is in between yn and yc. So in this case, dy by dx is negative, or h2 profile is a drawdown curve. So the profile is starting from zone 2 and flow depth is decreasing in the direction of the flow. So that means this profile is a drawdown curve. In the third case, y is less than yn and yc. So in this case, dy by dx is positive, or h3 profile is a backwater curve. And you can see that flow depth is increasing in the direction of the flow. Now let us consider the practical examples of H profiles. So here the bed slope is horizontal. So we have the profiles H2 and H3. So H2 curve occurs when y is in between yn and yc. So dy by dx here is negative. So here you can see the H2 profile because of the sharp cut in the channel bottom. So flow depth is decreasing in the direction of the flow. That means H2 profile is a drawdown curve. And for H3 profiles, dy by dx is positive. So flow depth is starting from zone 3 and it is increasing in the direction of the flow. So this is an example of backwater curve. And this horizontal slope is very rare in nature. Now let us discuss about the adverse slopes. So for adverse slopes, bed slope is increasing in the direction of the flow. Since yn is imaginary, zone 1 is absent, only zone 2 and 3 are available. That means A2 and A3 profiles are available. So dy by dx equal to S0 minus SF divided by 1 minus q square p by ga cube. The first case, yn is imaginary, so there is no profiles are available. That means A1 is totally absent. In the second case, y is higher than yc. So dy by dx is negative, or A2 profile is a drawdown curve. So it is A2 profile is starting from zone 2 and the flow depth is decreasing in the direction of the flow. And for A3 profile, y is less than yc. So it is starting from zone 3 and dy by dx is positive here and the flow depth is increasing in the direction of the flow. So that means it is a backwater curve. Now let us consider the practical examples of adverse slopes. So here you can see that the slope is increasing in the flow direction. So for A2 profile, dy by dx is negative and it is starting from zone 2, and because of the obstruction you can see that flow depth is decreasing in the direction of the flow. And for A3 profile, it is starting from zone 3. Since dy by dx is positive, flow depth is increasing in the direction of the flow due to the opening of this sluice gate. So here you can see that A2 profile is a drawdown curve, whereas A3 profile is a backwater curve. In nature, adverse slopes are available, but it exists only for short stretch. Now the session comes to an end. We started with the definition of gradually varied flow, and we have discussed about the classification of the slopes by considering critical slope as the criteria, discussed about the different flow zones, practical situations where various type of water surface profiles are occurring, and how to find out the type of water surface profile, whether it is a backwater curve or whether it is a drawdown curve. So for the time being it is enough. Thank you for your patient listening.